You know, there's a kind of Colossus effect happening in computing right now. Something so enormous, it's literally reshaping our energy grid, our supply chains, and even global politics. So let's break this down. Let's look at how this new Colossus, a machine the size of a city, is being built not for people, but for pure intelligence.
Okay, so at the absolute center of all this is a project called Colossus 2. It's from XAI, and the plan is to bring nearly 1 million GPUs online, all under a single roof. I mean, that number is staggering. But honestly, the what here is way less interesting than the how.
Because the truly mind-blowing part of this story is the speed. Back in March of this year, this whole thing was just an abandoned factory, an empty shell. By September, it's going to be one of the most powerful supercomputers on the entire planet. Building anything at this scale in just 6 months, well, it's basically unheard of in this industry.
Now, to really wrap our heads around what's happening here, we have to stop thinking about this as just a data center. That word doesn't really cut it anymore. A much better way to look at it is as 4 separate, gigantic industrial plants, all working in concert. You've got power, cooling, networking, and then finally the compute itself. And if just one of those fails, the whole thing comes crashing down. So let's start with the first and honestly the most fundamental factory, power. Because you don't kick off a project like this by ordering silicon chips. No, you start with the brutal, simple challenge of finding and teaming a gigawatt of raw power. Without that, all those expensive racks just stay dark. And right here is where this whole project almost died before it even started. See, Colossus needed a full gigawatt of power. That's 1,000 megawatts. The entire city of Memphis, Tennessee, could barely scrape together 50 for them. The gap was just enormous. Regulators basically said no way, and for a minute there, the project looked completely dead in the water. So the team did something pretty extreme. They hopped the state line into Mississippi, found an old power plant site, and then they did something that sounds kind of crazy. They bought an entire gas power plant from Europe, had it broken down into modules that could fit in shipping containers, and then sailed it across the Atlantic to be put back together again. It sounds insane, but it was actually faster than trying to build a new one from scratch. And this power problem, it's only getting harder. We're used to server racks pulling maybe 50 kilowatts, but with NVIDIA's brand new Blackwell chips, that number skyrockets to 130 kilowatts per rack. Just one of these new racks will pull as much electricity as a small neighborhood. Think about that. So how do you actually manage that much power stably? Well, it's not as simple as just plugging it into the wall. The power flows through this really clever layered system. It starts at the grid, then it feeds into 168 of these giant Tesla Megapack batteries. These act like a massive shock absorber, smoothing out the violent millisecond-long power spikes the GPUs create. Only then is that clean, stable power sent to the racks. All right, so our power factory is up and running, but that creates an immediate and massive consequence. The second all that electricity hits those servers, it creates our next great enemy, heat. So let's move on to our second factory, one built entirely to tame all that heat. This quote just perfectly nails the scale of the problem. All that energy has to go somewhere, right? So a 1 gigawatt data center produces 1 gigawatt of waste heat. That is literally the output of an industrial power plant, but it's all trapped inside 4 walls. If the cooling system stops for even 2 minutes, the entire supercomputer starts to melt down. At this scale, you can forget about air conditioning. You need water, and you need a ton of it. And this has created a really serious environmental problem because these massive data centers are often built in places that are already in a drought, like Arizona, forcing them to compete with cities and farms for a resource that's already incredibly scarce. So XAI's solution was, once again, pretty extreme. They just built a second factory right there on campus, a water factory. What it does is take dirty wastewater from the city of Memphis, run it through the world's largest ceramic membrane bioreactor, and it produces 13 million gallons of pure water for cooling every single day. It's one of those rare cases where a data center might actually improve the local water situation. Okay, so we've got our power factory and our cooling factory. But believe it or not, that's still not what gives a machine like Colossus its real edge. The true advantage is hidden deep inside the machine itself, in the network that ties everything together. This is such a crucial point to understand. A modern AI supercomputer is not just a big warehouse filled with servers anymore. It's a fundamentally different kind of beast. A million GPUs don't mean a thing if they can't all work together as one single unified machine. So, if it's not just a big collection of computers, what exactly is it? I mean, how on earth do you get hundreds of thousands of processors to act as one? The answer is something called the network fabric. The best way to think about it is as the supercomputer's nervous system. It's this specialized, incredibly high-speed network that links every single GPU to every other GPU at mind-boggling speeds, keeping them all in perfect sync. Without this fabric, all you have is a room full of very expensive, very lonely calculators.
And this fabric connects a whole ecosystem of different chips. At the core, of course, you've got NVIDIA's Blackwell GPUs doing all the heavy lifting. But they're being directed and orchestrated by CPUs from AMD and Intel. You have high-bandwidth memory from SK Hynix just pumping data into the cores, and then petabytes of solid-state storage constantly streaming the training data to keep the whole machine fed. And the result of all of this? At launch, Colossus 2 is expected to deliver 50 exaflops of performance. Now, to put that number into perspective for you, that is 7 times more computing power than the world's top 10 fastest supercomputers combined, all in one building. Now, let's zoom out for a second, because as incredible as Colossus 2 is, this isn't some isolated event. What we're seeing is the opening shot in a brand new global arms race, a race for gigawatts. The new reality is that whoever has access to stable, abundant energy is who's going to be able to train the best AI models, period. And because of that, AI labs are quietly turning themselves into energy companies. I mean, you have Microsoft helping to restart a nuclear power plant, and Google is funding new ones, all just to secure enough power for their AI ambitions. And you can just see the escalating scale here. Switch's Citadel campus, that's a monster at 650 megawatts. Colossus 2 is nearly double that at 1.2 gigawatts. But then you look at what OpenAI is planning with their Stargate project, they're aiming for up to 10 gigawatts of power. These numbers are just becoming astronomical. And the costs are just as colossal. Of the estimated $20 billion price tag for a project like this, only about half of that money actually goes to the silicon and the servers. The other half, we're talking billions and billions of dollars, is spent on the power and cooling factories needed just to keep the whole thing alive. And this all brings us to a really fundamental question for our society. We are building an entirely new, power-hungry industrial layer that relies on the exact same resource that every city and every nation already depends on. And as this race accelerates, we might actually have to decide who gets that energy, people or machines.